Welcome to the Explainer. Sometimes the biggest things in AI come down to just one tiny number, and that number is called the learning rate. It's basically the speed dial for how fast an AI can learn, and getting it right, well, that's everything.
All right, so let's just dive right in. How does a computer, actually learn from its mistakes? When we say an AI is learning, what is really going on?
Okay, so at its core, the goal is actually super simple. You want to get the AI's guesses as close to the correct answer as possible. That gap between the guess and the truth, it has a name. It's called loss. And really, the whole game is just trying to shrink that loss number down to practically zero.
To really wrap your head around this, let's paint a picture. Imagine you're on a journey down a really foggy mountain. Your goal is to find the absolute lowest point in the valley, but you can't see a thing. You can only feel the slope of the ground right under your feet.
So, where does this journey begin? Well, the AI starts out with its internal settings, we call them weights, set to just completely random values. It's like being dropped onto that foggy mountainside at a totally random spot. No map, no idea where you are. Okay, so there you are, on this foggy mountain, trying to get to the bottom. Which way is down, right? You need some kind of tool, a compass.
And in machine learning, that compass has a name. It's called the gradient. Now, without getting too math-heavy, it basically just points you in the direction of the steepest downhill slope from wherever you're currently standing.
So here's the key thing to remember. The gradient is our compass, but instead of pointing north, it's always pointing in the direction that will shrink our error, our loss, the fastest. It's literally our guide down the mountain.
But just knowing the right direction, that isn't the whole story, is it? You still have to decide how big of a step to take.
And this right here, is the whole point of our explainer today. The compass is pointing downhill. Fantastic! But now what? Are you going to take a tiny little shuffle, a normal-sized step, or a giant, massive leap?
Well, that step size, that's what we call the learning rate. It's this small number that basically tells the model how much to adjust itself based on what the gradient is telling it. Think of it like the throttle on the learning engine.
And picking this number, this learning rate, man, it is a dangerous balancing act. Get it wrong, and the consequences for the AI's training can be, well, pretty dramatic.
This is what I like to call the Goldilocks problem of machine learning. You see, if your learning rate is too high, like on the left, you're taking these giant leaps, and you could just jump right over the bottom of the valley completely. But on the other hand, if it's too low, you're just taking these tiny, little baby steps, and your journey to the bottom is going to take, forever.
And this isn't just a minor inconvenience, it's a huge risk. As this quote points out, if you set that number too high, you could just overshoot the target completely. I mean, imagine jumping so far you actually land on the other side of the valley, higher up than where you even started. That can happen.
So what are we talking about here, numbers-wise? Well, they're probably a lot smaller than you'd think. We're talking about values like 0.01 on the high end. A more common value is something like 0.001, and on the low end, you might see 0.0001.
And this is maybe the most important thing to get. There is no magic number that works for every model every time. The learning rate is what's called a hyperparameter. Just think of it like a settings knob on the outside of the machine. The person building the AI has to experiment, they have to test and tune this knob to find that just right sweet spot for their specific problem.
All right, so that's the theory. It's a fun analogy with the mountain, right? But what does this actually look like when you're writing the code? Okay, so the actual update process is this simple little three-step dance that just repeats over and over and over. First, you figure out which way is downhill. That's calculating the gradient. Second, you multiply that direction by your learning rate to decide how far you're going to go. And third, you take the step. You update your weights.
And believe it or not, in the actual code, this is super straightforward. If you're using a popular framework like Keras, when you set up what's called your optimizer, that's the engine that does the learning, you can usually just set the learning rate, which is almost always abbreviated LR, as a simple parameter, just like you see here.
But what's really cool is that you're not locked into that one number for the entire training process. A really common strategy is to start with a bigger learning rate to make fast progress at the beginning and then make it smaller later on. It's like taking big leaps when you're far away from the goal and then switching to careful, tiny steps as you get really close to the bottom. Okay, so let's just recap the big ideas here. The learning rate. It's the step size the AI takes while it's learning. It's a total balancing act. Go too high and you overshoot, go too low and it's just painfully slow.
And most importantly, it's a critical knob, a hyperparameter that you absolutely have to test and tune to get right.
And that leaves us with one last question to kind of chew on. If finding the perfect learning rate is so dependent on experimenting, on intuition, on just plain old trial and error, it really makes you wonder, right? Where does building AI stop being a pure algorithm and start becoming more of an art?